Welcome dear students. This is the second lecture of Unit 2 in your course Elect Agron 311 Agricultural Waste Management, which is the elective course of your BSc Agriculture program in 5th semester. Today our topic is recycling of agricultural waste. Here in this topic, the course content or the contents in this lecture are recycling of agricultural waste, preparation of raw material, because there is a process of recycling or process of its utilization. For this process, our agricultural waste is used as a raw material, but according to the process, this raw material is to be prepared first. Though it is collected as agricultural waste, but it should be prepared according to the process. So it comes under the preparation of raw material. Then there are 2-3 slides on flow diagram of recycling of agricultural waste, and I will discuss in detail about the biogas production part. Means these wastes are decomposed anaerobically. So two things are produced, one is biogas, another is slurry. So these two things, how it will be utilized, the biogas, the benefits of biogas and how the biogas are utilized, that will be discussed in this lecture. And the remaining part, that is digested bioslurry, the use of that part is also will be discussed in this lecture. So here in this lecture, even in last lecture, which was based on the biological management of or biological degradation of agricultural waste, I have given you the idea that there are two processes through which we can manage it. Aerobic process and anaerobic process, both. What are these processes? I have explained it. So that one part, that is anaerobic process, that will be discussed here in detail. So the process will be discussed here in detail, and how it will be done, that will be the part of your next lecture. So waste recycling is a process to change the waste into new product. So these wastes are taken to a unit, some processing is done, and it is changed into a new product. This is the waste recycling. This prevents the waste of potentially used material, because we have certain materials which we consider as agricultural waste. These material has some potential use. So if we will not go for the recycling, that material will be lost. So to prevent that waste material, to prevent the material to be wasted which are of potentially useful. Even for the unit they produce the new product, this agricultural waste will be the raw material for that production unit. So the original or the fresh raw material which they procure for their consumptive activity, the fresh raw material can be saved, or the reduction of consumption of fresh raw material is a consequence of waste recycling. Next advantage is that it reduces the energy uses. Another advantage of waste recycling is that it reduces the air pollution from incineration of water pollution from it reduces the air pollution from insemination. This is one part. Another part, it also reduces the water pollution which happens because of land filling. Land filling means the area where the waste is dumped, and again the waste is dumped, and some waste are dumped in a lower surface which are just covered, and this anaerobic situation is occurred there, they decompose there in open yard for a longer time. So that yard where the waste is decomposed, that is called as landfill. So from that area, from the landfill area, water pollution problem is a very big problem. So this landfill area contributes a lot in water pollution. Even this eutrophication, which is the overnourishment of water bodies, this comes from this landfill area. So if we go for the recycling of waste, this water pollution can also be reduced. It lower the greenhouse gas emission. Even in last lecture it has been discussed that if the waste, if the organic waste or the agricultural waste, if it is dumped in the open yard, aerobic, anaerobic, both digestion or both decomposition process occur simultaneously, and because of anaerobic decomposition process, greenhouse gases is emitted into the atmosphere and it pollutes the environment. If we manage it, then this greenhouse gases emission can be lower down. So process is to reduce, reuse and recycle. This is the process of waste management. This is the third component. And this waste management, here I will discuss that how it is managed to produce biogas. So biogas, I don't know. So biogas is a gas which is produced by the anaerobic decomposition of organic material, which is the igneous gas rich in methane, and methane is the igneous component of that gas. So biogas is produced from that anaerobic decomposition of waste. So this process of recycling of waste or the processing of waste, anaerobic decomposition of waste, agricultural waste to produce biogas, first we have to collect the waste. When we collect the agricultural waste, it may have several metallic part, it may have some paper part or plastic part. So the preparation of raw material means the unit where the waste is being feeded for the biogas production, this plastic or paper part will not work in that unit, and so there will be a problem of decomposition or anaerobic decomposition of our agricultural waste, and even the maintenance of the unit, maintenance of the production unit of biogas, the maintenance will be increased. This is the reason that we should feed only bio waste or only the organic waste to the biogas production unit. That's why this raw material is to be prepared. So this raw material is prepared by selecting the only degradable waste or only the biodegradable waste or organic waste, and the metallic part, paper part, plastic part, it is selected and taken out from the lot of the agricultural waste. Even the dirt, soil particle, stone and foreign particles, it is not allowed to feed in the biogas assembly for the anaerobic digestion or for the anaerobic decomposition or for the biogas production. So if lot of dirt or the soil is associated with the agricultural waste, first we have to wash it and clean it, so the dirt, soil, it should not be there. Even some biogas assembly, in next lecture I will tell you that how the biogas unit or the biogas production unit works. It may be the biogas production unit, it may be smaller and it may be a larger one also. So the larger one or the large biogas unit which is installed in several factories, they have de-stoner machine also. And for the smaller biogas unit at village level or at farm level, These stone, as I am telling you, that you have to pick up the metallic and plastic part, metallic, plastic and paper part from the waste. Stone also you have to pick it out. These factories, some factories, they have a special machine that is known as de-stoner. So these organic waste, they pass it first through the de-stoner. Stones is collected somewhere else, and the clean material, clean means the material which is good for the feeding in biogas production unit, that is the organic waste, that material is collected and that is fed for in a biogas unit for the biogas production. So any raw material which is not digestible should not be present in the waste. This is a main purpose, that before feeding this organic waste to the biogas material, we will have to work over it. The waste which are suitable for biogas production, these are crop residue, these are animal byproducts, these are food residues, or the kitchen waste or the kitchen food which is taken out from our kitchen, waste from food processing units, and all other organic waste. So that's why I am saying waste from food processing units. So all the food processing units, even the companies which are giving you the mango juice, they are processing the mango, and so they have installed a biogas production also as a management of waste generated from the food processing unit. Because these factories or these companies which are engaged in the processing of mango and their end product is mango juice, these companies cannot throw the waste just at backside of the company in a yard, in an open yard. It will pollute the environment, and the license of company running, it can be barred by the government, because their commercial activity should not harm the environment. That's why it is compulsory for the companies that they should install any unit to manage the waste also. They should not harm the environment. So they are also these companies are also installing these biogas production units. So the waste from food processing sectors, these are used or consumed for the biogas production. So this is the layout of recycling of agricultural waste for biogas production. This is a comprehensive diagram which will tell you from the whole cycle from start to end. These are the waste. These all are, except this. These all are the waste. This is animal manure. This is fruit and vegetable waste. This is waste from industries, means food processing industries. These are crop residue, dairy waste, poultry waste. All waste can be utilized for biogas production. So these waste are first collected and it is put in a tank for hydrolysis. So the first process of waste recycling is hydrolysis. First the waste is hydrolyzed, then after the hydrolysis of the waste, some water is coming out from the hydrolysis. That water is rich in nutrient. So that water can go to your feed. After this hydrolysis, this wet waste material or this waste material with water, it will go to the digester. This digester is anaerobic digester because it is a closed chamber. Anaerobic digestion occurs here. Methogenic bacteria works in this digester, or methogenic bacteria work in this digester, and the waste is digested by that bacteria and slurry is produced. And as the result of, because bacteria will grow there, they will feed over the waste and they will grow their population. But as a growth of bacteria, or as they are using the feed for their growth, this bio waste as a feed, and it is converted into the another form. So that And in that process, bacteria also respire, but it respires in the absence of oxygen. So these are the methogenic bacteria, and it generates methane. So a gas is generated in this closed chamber. That gas is known as biogas. What is biogas? That I will tell you later. This biogas is the igneous gas. If it is an igneous gas, so it can be used for the ignition. When it is used for the ignition, these gas can be used as CBG, compressed biogas, or it is a form of CNG, compressed natural gas. It can be used in automotive industries, or it can be used as a fuel for automotive industries. These biogas can also be used for igniting the engine for producing the electricity. So a power generation, that's why this biogas, it comes under MNRE, Ministry of New and Renewable Energy. So the lot of biogas at industrial level, it is used to ignite the engine, and this engine will generate the electricity, and the electricity which is generated by the unit, either the company can consume it himself, or the company should feed the government grid. So power generation is a activity which is a beneficial activity, or which is the end product. Power is the end product which we get by managing the agricultural waste. Next, this biogas is used for cooking gas. So clean fuel for cooking gas. Thus biogas is considered as a clean fuel for cooking. So this biogas can be supplied to the houses through pipeline, and it will burn your burner or your furnace for food cooking. So these are the use of biogas. The waste material after hydrolysis is transferred to the anaerobic digester, and through the activity of methogenic bacteria, biogas is generated. It is utilized. Still some waste material will be left in the digester. That waste material, after the completion of this process, gas generation and energy utilization, after the completion of process of gas generation, these are the utilization of gas generation process is complete, still the waste will be left in the digester in another form. Definitely it will be in another form, because it has already fed by the microbes. So the waste of another form, that is called digested bioslurry. This digested bioslurry again can be utilized as a crop manure or soil amendment or crop manure, and it will supply. This is a very good manure for the crop. Even for the organic production, organic agriculture, this is a very major constituent or major part. It will go to your field for the crop production. Then again from the crop production you can get some waste material, and this waste material can be again go to the hydrolysis. So the cycle is complete. So this way the recycling is done. So how this biogas, how this works? So as here you see that this waste first go to the hydrolysis, then anaerobic digestion. This process is like this. These are the waste. Waste material are rich in carbohydrate, fat and proteins. These waste material which are rich in carbohydrate, fat and proteins. Carbohydrate, fat and proteins are the organic compound. They are the complex organic compound. These complex organic compound is converted into the form of simpler organic compound. Again, sugar is organic compound, fatty acid is organic compound, amino acid is organic compound. So these complex organic compound is converted into simpler organic compound by reacting it with the water. Hydrolysis. Hydro means water, lysis means breakdown, lysis means breakdown. Hydrolysis or hydrolysis people used to say. Hydro means water, lysis means breakdown. So the breakdown of complex material to a simpler organic. The breakdown of complex organic material to a simpler organic material is hydrolysis in presence of water, or in the with the reaction of water is known as hydrolysis. When it is converted into the simpler organic form, it will be very easy for the bacteria or for the microorganisms to feed over it. So these acidogenic bacteria will act over it. Acidogenic bacteria will feed sugar, fatty acid and amino acid, and these acidogenic bacteria will release carbonic acid, alcohol or ammonia or hydrocarbon dioxide. After acidogenic bacteria, they convert it into carbonic acid and acetic acid. Then acetogenic bacteria works over it and convert it into acetate, acetic acid or acetate. Then in the absence of oxygen, the whole process is after the hydrolysis, the whole process is in absence of oxygen. It is anaerobic process. So this process go forward. First acetogenic bacteria works even in the absence of oxygen. Then acetogenic is also acidogenic because they generate acetic acid. So it is acetic acid, so it is acetogenic bacteria. So they generate acetic acid or acetate. Then this methogenic bacteria, they feed over it in the absence of oxygen and they generate methane. That's why this is known as methanogenic bacteria. So this methanogenic bacteria produce the end product, which is biogas. This biogas is the combination of methane and carbohydrate. This is not only the combination of methane and carbohydrate, it is a combination of methane, carbohydrate and hydrogen sulfide. So this is the flowchart of process of biogas generation. This is our waste, protein, carbohydrate and lipid, and the whole process is fermentation. This after the hydrolysis is converted into simple sugar, and even during hydrolysis some bacteria will act over it, and then it goes to the anaerobic digestion chamber. Here the fermentive bacteria, the process is of three way. Fermentive bacteria will convert it into short chain volatile fatty acid, or directly this fermentive bacteria can convert these amino acid sugar into acetate or into water and carbon dioxide. This is the reason that even in biogas carbon dioxide is present with methane, because they utilize the carbon of dead material or the carbon of organic waste, and they utilize the oxygen of water, and these are the hydrogen consuming bacteria, so they consume hydrogen also, and they convert it into carbon dioxide, and then protein, biurate, etc., the short chain volatile fatty acid, it is also they also produce hydrogen and carbon dioxide. If it is hydrogen producing bacteria, if it is hydrogen consuming bacteria, they produce acetate. So we have two type of bacteria. One is hydrogen producing bacteria and another is hydrogen consuming bacteria. So some bacteria produce hydrogen, some consumes hydrogen, and ultimately some hydrogen is produced because our waste is hydrocarbon. So hydrogen, carbon and oxygen will be produced. So the end product is methane and carbon dioxide, and a little amount of hydrogen sulfide is also present there. So sulfur, because sulfur is also the part of volatile fatty acid, sulfur is also the part of amino acid, so hydrogen sulfide is also produced, and hydrogen sulfide is a bad odor gas, even harmful gas and greenhouse gas. So this way Even methane is a greenhouse gas, carbon dioxide is a greenhouse gas. So all the combination of three, methane, carbon dioxide and hydrogen sulfide, is produced. So what I told you, these gases are collected and utilized as a automotive fuel or as a power production or as a fuel, a clean fuel for cooking. So now what is the difference? How you can see that this recycling of agricultural waste is beneficial? If you remember my last lecture where I have explained that problem or impact of agricultural waste on environment, in that lecture, impact of agricultural waste on environment, I have discussed two parts. One is burning, another is open yard dumping. So in open yard dumping, anaerobic process occurs, and even in open yard dumping, the process will be same. Even in open yard dumping, if the anaerobic decomposition will be there, and definitely it will be there, because in the heap, in the inner side of the heap, air cannot go, and anaerobic decomposition process occurs there. And this methane, carbon dioxide and hydrogen sulfide is generated, and it is emitted into environment and polluting the environment. In our unit where we are producing biogas, this gas is generated, but here we are utilizing it for our energy generation purpose. So the gas is utilizing and not polluting the environment. It is utilizing for energy generation, and then it is consumed. So this is the importance. In open air dumping, it pollutes the environment, but the controlled decomposition means in a biogas unit we channelize these biogas, and even we can channelize that. Even one more thing I want to tell you, this biogas will ignite the engine and electricity is generated. Lot of heat is generated there. Then heat is transferred to the vapor absorption machine and a cooling effect is generated. So everything energy can be utilized. So these are the composition, use and advantage of biogas. So the biogas which is generated through the process which I have already explained you, the composition of this gas is 60 to 70% methane, 30 to 40% carbon dioxide, 0.05 to 2% hydrogen sulfide. This composition depends on the raw material which is used as a feed for biogas plant. So this is the composition of biogas. What are the use of biogas? Even initial slide I have explained. It is a natural gas. It is a part of, or it can be substitute of a CNG as a CBG, compressed biogas. So natural gas, this is a natural gas after purification. For combustion and production of heat and light, this gas can be used. Electricity generation using biogas engine and generator. Our vehicle, can be used as a fuel vehicle, or it is a fuel cell, or in a fuel cell this biogas can be used. Advantage of this waste recycling, it is eco-friendly, it is renewable in nature. Why it is renewable? Because it is giving you the new energy. The clean combustion fuel. This gas can also be used for domestic and commercial application, and it will also give you good potent organic fertilizer. So this is the organic fertilizer, because here I told you the two things are generated. One, gas is generated. Even here the process is for the gas generation. Here again the process is layout is for the process of gas generation. But I told you, after the gas generation, the waste is remained in the digester. That remained waste is known as byproduct of biogas, it is digested bioslurry. So this digested bioslurry is taken out from the digester, this anaerobic digester. This bioslurry is taken out. When you take it out, lot of water will also be present there. So it is just a mix of solid and water. So you will have to remove the water separately and solid separately. So there are two methods. One is known as belt press method, another is known as screw press method. Means you have to press it. When the whole slurry you press it, solid will remain there and water will go out. So one is screw press method, means it is dumped in a cylinder, a screw is rotating and this rotating screw will press it and water is taken out through the sieves and waste is collected at outside. In a belt press method, again this waste is passed on a belt. We pass it on a belt with a roller. This belt is a sieve. So this roller will press these waste on a this roller will press this waste, this digested bioslurry, on a belt which is perforated having sieves. So the water is taken out and then again the belt will collect the solid material somewhere else. So liquid and solid is separated. The liquid can also be used for crop spraying, because this liquid which we collect, that is it is not oxygenated, because it is collected from the anaerobic unit where all the reactions occurred in the absence of oxygen. So this liquid is directly cannot be applied in the field because it is less in oxygen. So it can be collected in a pond and we can oxygenate it just by rotating a fan in it. We can oxygenate it. Then it can be used, this liquid can be used in our farm, or this liquid can be used for the crop spraying. And the solid material which can be dried and used as a compost, as organic fertilizer. So the composition of this bioslurry is, it is 93% water and 7% dry matter. It contains, when you separate it, dry matter, your organic manure which is prepared by the slurry. It has 0.25% nitrogen, it has 0.13% phosphorus, it has 0.12% potassium. So this is a very good organic manure. So this is the characteristic of bioslurry, that it is fully fermented. So bioslurry is odorless and doesn't attract any flies. इसमें कोई बुरी बदबू नहीं आती है, मक्खियाँ इसके ऊपर नहीं मंडराती हैं. Bioslurry repels termite and pest that are attracted to raw dung. जो कच्चा गोबर है उसकी तरफ बहुत सारे टर्माइट्स और पेस्ट आते हैं. When you apply this bioslurry to your field for organic farming, even the termite and pest control can also be then advantage. This bioslurry reduces the weed growth. Application of bioslurry has proven to reduce the weed growth up to 50%. Bioslurry is an excellent soil conditioner. I told you, by the application of this bioslurry to the soil, your soil texture or your soil structure is improved, the infiltration capacity of soil is improved, water holding capacity of soil is improved. So it adds humus to your soil, enhance the soil capacity to retain water. So bioslurry is pathogen free. It is fermented of dung in the reactor, kills organism causing plant disease. So this bioslurry is pathogen free. So when you apply this in your soil, it will not, the pathogens which can spread disease in your plant, it is free from that pathogens. Spraying bioslurry with additional pesticide is good for the aphid and spider control. The effect of bioslurry with 15 to 20% insecticide in pest control is proven to produce the same result as produced by the using pure insecticide. So these are the advantages of bioslurry and the liquid of bioslurry. It can be used in our organic agriculture. So this is the outcome that today we have understood that this agricultural waste can be recycled. Importance of this biogas, importance of this waste management in environmental control. See, again I am telling you, if the waste is dumped in open yard, it will produce methane, hydrogen sulfide, and carbon dioxide, but it will pollute the environment. But when we do it in our digester, we collect that gases, we utilize that gases in energy generation, and we reduce the environmental pollution side by side. So the use of biogas we have understood here, and the use of digested bioslurry, how this digested bioslurry is beneficial in our agriculture, that also we have understood in this lecture. This is the reference that you can read, that how to convert organic waste into biogas, a step-by-step guide through this website. Thank you very much, dear students.